while back I talked to you about the real number system and how the natural numbers, the whole numbers, the integers, the rationals, and the irrationals all make up the real number system. Now, the real number system, with its operations of addition and multiplication, manifests things that we call properties. We can use them as we're trying to prove things, as you'll find out as you go on in math. And in higher math, the properties that the real number systems manifest are called the field properties. Now, I'm a little disappointed that sometimes the textbooks leave out some of the properties, and I've actually had to write 2 sets of programs for reviewing the properties, one for myself because it contains all the field properties, and one for the rest of the world that wants to leave some of them out. So I hope that you'll learn all the field properties of the real number system. It's not that impossible. I need you, though, to make a little excursion with me because I want to talk to you about one of the properties that they like to leave out. It's called closure. Okay, ready? Okay, I've got a basket here. I was looking around the house for a basket, and I probably could have found a more suitable basket, but I found this one and I thought you would like to see it. Look at it. It's made out of slices of, I think, walnut. Look, sliced, glued together. I don't know who made it. It was given to me by a woman I knew. She's passed away now, but she gave us the most interesting presents. She'd find things like this, and she had them in her collection, and one day she said, I thought you might like to have this. Look at it. It's so beautiful. Can you believe somebody took all that time to make that? So since we have such a wonderful basket, I want you to use your imagination with me to pretend that all the real numbers are in here. Like 4 is in there, a half is in there, the square root of 2 is in there. Every real number is in there. Pretend, okay? Now we say that the real number system is closed under the operations of addition and multiplication. What does that mean? That means that if you took any number out of here and took any other number out of here and you added them, the answer that you would get would also be a number that was in the basket. Is that hard? Not so hard that you can't get it. It's called closure, that when you add 2 numbers, you always get a number that belongs to the set. When you multiply 2 numbers, you always get a number that belongs to the set of the real numbers. This always reminded me of something that happened in junior high. You know, we used to have these junior high dances. The 50s were not that wild. A junior high dance meant that we all went to the school, took our shoes off because we wouldn't want to damage the new gym, took our shoes off, put them in a pile, and the girls stood on one side of the gym, and the boys stood on another side of the gym, and somebody played records, and a few couples danced, and then when the time was over, maybe some people bought refreshments. When the time was over, we would go look for our shoes and go home. That was our dance. But they didn't want these dances to be bombarded by people from one of the other schools. So they would say that the dance was closed, by meaning that it was closed to the outside. It had to be just students from our school. So when we say that the real number system is closed for the operations of addition and multiplication, that means whenever we add 2 numbers that are real, we get a real number. Whenever we multiply 2 numbers that are real, we get a real number. This is the property of closure. Got it? It's not that bad. I don't know why they leave it out. We're not going to. See, now, I promised you that we would be looking at 2 programs. If you go to Foundational Topics, you'll see Properties, a program called Properties, and a program called Field Properties. Properties is the one where we leave out some of the properties. In field properties, they're all there. If you're really going to be advanced, and I know you want to be, we need to look at the field properties. But just in case you only want to get ready for the ones that your teacher might probably ask you. We could look at properties. These are the things that they have under in the textbooks, all of them: commutative, associative, distributive, identity, inverse, and zero properties. And now let's look at the field properties. There's commutative, associative, distributed, identity, inverse, closure. So we have this other property called closure, and there's more distinction made for the different properties. Now we could look over here and see what they are. There's the associative property of addition, associative property of multiplication, commutative property of addition, commutative property of multiplication, closure for addition, closure for multiplication, identity element for addition, identity element for multiplication. See all those properties. These are the field properties. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 properties. The additive inverse and multiplicative inverse. So I'd like you to learn all of these properties, and we'll close this again and look at the other one and see how few they have. They don't separate them. See, they just say associative. They don't say for multiplication or division. They just scale them back, and I guess they think if they teach you a few of the properties, that's good enough. So you've got to check with your teacher and make sure that you're learning what they say, but I would like it better if you would learn all the field properties. So I'm just going to talk about commutative. I'm going to talk about some of these words. We already talked about closure. Commutative. When I was thinking about going to college, some of my friends were talking and everybody said, are you going to live on campus or are you going to commute? A commute meant that we were going back and forth from school to our home daily instead of going there and staying. Commute, go back and forth. So we want to get that in our head. Now let's talk about associative. Whenever I see the property associative, I sometimes can hear some mother upset because she doesn't like the friends that her child has. She said, I wish you wouldn't associate with them. That means hang out with them. When I hear the word distributive, it makes me think about distributing, passing out papers, distributing candy, giving out prizes, distributed. Identity sounds like identical twins. Identity meaning the same. Inverse, excuse me, there's an additive inverse, there's a multiplicative inverse. They get back to the identity element. Then there's closure. I'm going to work some of these problems, and maybe you'll catch on while I work these. What I find is with this program, it gives you an example, and then you have to name the property that's being demonstrated. And so at first it's a little crazy, but you'll see. 3 plus negative 3 is equal to 0. Well, 3 has what's called an additive inverse. Oh, the additive inverse of 3 is negative 3. When you add them together, we get back to the identity element for the real numbers. The identity element for addition is 0. So this is showing us the additive inverse. Additive inverse. Check. We win. New problem. 5 plus 6 equals 6 plus 5. You believe it. You've recognized that property. What this means is it doesn't matter whether you say 5 plus 6 or 6 plus 5. You can go back and forth on these numbers. If you've learned 5 plus 6, you've learned 6 plus 5. This is an example of the commutative property for addition. Check. We win. New problem. 9 plus 8 plus 2. with 9 plus 8 having parentheses around them, then plus 2. And then 9 plus 8 plus 2 with the parentheses around the 8 plus 2. Now you know the parentheses means that you do that first. So what this is saying is that if you're going to add three numbers, 9 plus 8 plus 2, 9 plus 8 plus 2, it doesn't matter how you associate them with parentheses. If you take the 9 plus 8, that's 17, plus 2 makes 19. If you associate the 8 plus 2 and get the 10 plus 9, that's 19. The associative property says it doesn't matter how you associate them when you want to get the answer to more than two things together. So this is the associative property, and since we're talking about addition, it's the associative property of addition. Check, we win. New problem. 7 times 2 plus 7 times 4 is equal to 7 times 2 plus 4. This is an example of the 7 that's in front of this parentheses being distributed, passed out, to both the 2 and to the 4. It's like this 7 is standing in front of this house and says, I'd like to come and give everybody a prize. 7 times 2, 7 times 4. This is the distributive property of multiplication over addition. The distributive property of multiplication over addition. There's not two properties of this. There's this. Multiplication distributes over addition. No, we win. Oh, here's the same thing again. Do you know what this one is? We saw it before. 8. Oh, except we saw it for addition. Look, this is for multiplication. 8 times 9 times 7, 8 times 9 times 7. But this time the 8 and 9 are associated and then multiplied by 7. And here the 9 and 7 are associated and multiplied by the 8. This is a demonstration of the associative property for multiplication. Check, you win. New problem. 1 plus negative 1. This is a property of the additive inverse. Check, we win. 8 plus 1 is a real number. This is what I was talking about. 8 was in the basket, 1 was in the basket. When we multiply them, we get an answer, and it's in the basket. It's in the basket called real numbers. This is closure for multiplication. 3 plus 5 is a real number, almost like the last problem, except because it's plus, it's closure for addition. Check, you win. New problem. Oh, another closure one. Closure for multiplication. Check, we win. Another associative for multiplication. Check, we win. Oh, we get this exercise, guy, because we're so good. 10 questions are right. 2 equals 2 plus 0. 0 is a very special number. It's called the identity element for addition, because whenever you add it onto something, you get the identical answer. So this is a demonstration of the identity element for addition. Check, we win. Another associative for addition. Now this progress report's going to tell us that we haven't had commutative of multiplication. We haven't had the identity element for multiplication. I guess we better keep going on until we bump into that. Now, here's a different one. 6 times 1/6 equals 1. 1 is the identity element for multiplication. So this is an example of the multiplicative inverse. See, the multiplicative inverse of 6 is 1/6. which gives you back the identity element for multiplication. So this is the showing the multiplicative inverse. That's a real number. Closure for multiplication. New problem. This is 2 times 3 plus 2 times 9 is the same as 2 times 3 plus 9. See how the 2 is distributed? This is the distributive property of multiplication over addition. Now we're up to 20. We still haven't gotten that. Here we go. 7 plus negative 7 equals 0. This is the identity element. No, this is the showing the additive inverse. Gives us back the identity element. We're just not getting that other one. Maybe I should just tell you. 7 times this is, go back and forth. What is it? He's commuting. Commutative property for multiplication. And associative property for addition. Distributive. Man, if you're doing this with me, we're on a roll. This is the identity. This is the additive inverse. Gives us the identity element. Distributive. I guess I better tell you what those other ones are, because it doesn't look like we're going to get this. This is associative property for multiplication. Once more into the breach. It's associative for addition. Let's look at our progress. We still have nothing for the identity element for multiplication. The identity element for multiplication would be this, like 5 times 1 equals 5. That would be an example. The identity element for addition would be 5 plus 0 equals 5. That would be demonstrating. Anyway, if you keep practicing until you see that your progress, that you're getting 4 or 5 of each one, it's child abuse, but you will learn your field properties and you will be ready for understanding fields. When you get to graduate school, it's a lot harder then. But okay, take heart. Learn the field properties now. Thanks. Bye. When we were talking about the properties and the field properties, I failed to mention that there's a property that's listed in the properties program that helps the textbook, what's in the textbook, and that's the zero product property that they have in most of the textbooks. And it's not in the official field properties here. You don't see that one. So I guess you're going to have to do both of these programs. It wouldn't hurt a bit if you did both of them. But when I was thinking about how I needed to warn you about the zero property program, it dawned on me that I probably should say some things about inverses and identity elements, so we can clear that up, because I'm not there to answer your questions. So let's see what's going on here. I'm just going to bring up a paint program, and we want to talk about the word identity. Looks a little bit like identical, identity meaning the same. And we have the identity element, one for addition and one for multiplication, our two operations on the real numbers. So if you take a number and add the identity element to it and get the same number that you started with, then that thing that you add is the identity element for addition. If you take any number and multiply it by some number and get the same thing that you started with, that's the identity element for multiplication. So we're after the identity elements for addition and for multiplication. Now, while I've been writing this down, I hope you were thinking, what number can you add to any number and get that same any number back? Well, it would be 0. So 0 is the identity element for addition. What number would go here? What number times any number would give you that any number back? Well, it would be 1. So 1 is the identity element for multiplication. Okay, got that? Now, when we have these identity elements, let me see if I can't move this up a little bit, see if that's going to work for me. Yeah. So we have the identity element for multiplication and addition. Now, we have the concept of an inverse, because sometimes it's desirable to get the additive inverse as the answer to a problem. So what would you have to add to a number to end up with the identity element for your answer? Well, turns out that you would have to add its opposite. So this is the opposite, leads to, this is the opposite or the additive inverse. And the multiplicative inverse, which would end up in the identity element for multiplication, is 1 over a, and that's the multiplicative inverse. I think I misspelled that. Multiplicative inverse. Not very good at writing. Now, in addition to these inverses, the additive inverse and the multiplicative inverse, there's this 0 property that when you multiply any number times 0, you're going to always 100% of the time get a 0. So sometimes you'll be asked to identify this special multiplicative property of 0. It is not the same as the multiplicative inverse. It's the 0 property, the multiplication property of 0. Okay, hope you got that. Practice the two programs and make sure that you can identify the properties. The program, if you miss one, the program will give you a button that will appear like magic that will say something about show me the answer or something, and you can, if you work it enough times, you'll be able to self-correct your problems.